1 and 1/5, okay? So if we plot these points, now with decay, you're coming from big and getting smaller. So you're coming from big and getting smaller. -1, 5, 1 and 1/5. And it's never, ever, ever going to go away. That's why it never goes below that x-axis. It just gets smaller and smaller and smaller. Okay? Okay, this one here. This is your A. And it's being multiplied by 2/3 every time and then by 3. So it's going to look a little bit different, but it's still decay because this is between 0 and 1. Okay? Every time you're multiplying by 2/3, it's making it get smaller. All right, so 0, 3, I'm just going to give you these numbers. Again, you can get them off the calculator or you could do them yourself. So over 0, up 3. Over 1, up 2. -1, 4.5. So it's a little bit fatter, if you'd like to say. I don't know how to say it's a little bit like that. That's because of the 3. But it still does not go below this axis right here. Still will not ever be 0. Now, ladies and gentlemen, before you move on, I just want you to observe, again, it's not just about how to, it's what's really happening here. Would you rather have a cookie be multiplied by 1/5 each time or 2/3 each time?
2/3.
2/3, right? You get more left over. So it decays slower. That's why it looks like this. It decays slower. Make sense? That's why they look different. Okay? All right. Again, here's the general equation. Y equals A times B to the X minus H plus K. So, let's just get a couple points. We'll start with that. How do I know it's decay and not growth? Again, this is between 0 and 1. It's getting smaller, being multiplied by 3/4 every time. 0, -2. 1, -1.5. -1, -2.7. I think I just got these off the calculator. Wait a minute. What's that? So it's going to make my decay graph do what? Flip over the x-axis. Okay. So let's plot these points. 0, -2. Over 1, down 1.5. -1, -2.7. Again, well, let's think about it. Before it flipped, it would be something like this. Don't draw this, I'm just saying. It's going to be something like that before we apply the negative, correct? And the negative is going to make it do this. And it doesn't decay too fast because it's 3/4. You have 3/4 left over every time you do it. So it's not decaying too fast. That's why it's kind of like stretched out a little bit. Got it? What's the domain here? What's the range? The y values are all what? Right on. Okay? Because this goes forever, doesn't it? And this goes forever. So really, any single point on here, x could be any number. Okay? All right, this one. Again, this is going up 1. This is decay. This is going right 2. And it starts at 2 originally. So what that's going to look like is, I'm just going to write this. We start with this. Let's just look at it this way. We start with this. And then what this stuff does to it here is make it go right 2 and up 1 is basically a way to look at it. I don't even have specific points for this. I know it starts here. It starts kind of here. This is my starting one. And from this point, it goes right 2, up 1. Okay? And then you can get points off the table. I don't really have specific points, but it kind of goes like this. What is the asymptote? What is it never going to go below? 1. So it's something like that. Because it got shifted up 1. Again, the domain could be anything, and the range y is greater than 1. The y's will never be below 1. All right, we got a decay model. The only thing that's different is that this thing inside here is called the decay factor. That number is going to be between 0 and 1. By the way, 0, 1. No, between 0 and 1, okay, when you subtract. T is time. R is the rate as a decimal. A is the initial. Okay, the cost of a new Lincoln Navigator is $57,775. The value of the car depreciates in value by 15%. You know, it's really like kind of a bad investment to buy a brand new car, unless you have a ton of money. As soon as you drive off that lot, it goes way down in value. Way down. But people do buy brand new cars, so they keep selling them. So R equals 0.15. Write an exponential decay model giving the car value y in t years. So I'm going to keep the t in there. I don't know what it is. I'm just writing a model where I can plug any amount of years in. So it's like this. Y equals 57,775. 1 minus 0.15, because that's my R, to the t. And then I'm going to consolidate this. That is my model. Now, the biggest thing I want to point out again, and this is from teaching algebra from so many years. If you're given a model like this and it says, is this growth or decay, can you recognize it? Yeah. Because that seems to be something that was a troubling thing as an 8th grader, but maybe not as your age. So, how can I tell it's decay?
Because it's less than 1.
Yes, okay. Estimate the value of the Navigator after 4 years. Are you ready? Only 4 years. Let's see what it's worth. Y equals 5, starting out at 57,775. To the 4th is approximately $30,000. So it went down almost half in 4 years. Okay? So, is this familiar to you?